Hi everyone, this week we're going to carry on from where we left off last week, and we're going to build two components that communicate using the IPC, the inter-process communication that's available within Greengrass. So where we left it last week was we had the blinky component that was running, and we've got this green LED here that's blinking every couple of seconds. And now we're going to build two more components, and they're going to communicate using the IPC. The first component we're going to build is going to make the red LED flash or respond to the push button, which is going to be the second component. So we call the first component lighty because it's a light, and carrying on from the naming convention. And we're going to have the button, push button, which we'll call buttony. So let's get started and log back in to the Raspberry Pi. So connecting via VNC. And here we are going to go into our component folder and build the artifact folders and directory structure that we need. So if I click in here, we're going to need a new folder which we'll call com sample.lighty, and another folder buttony. Okay, and within those folders we're going to have the first version in there, so a new folder in there, 1.0.0, and another folder within lighty called 1.0.0. And we'll make two Python files in each, so one in here and then we need to create the two recipe files that we're going to need. So I'm going to just create blank files for now and copy the code across later. Okay, so let's start with lighty first of all. I'm going to open that file in the editor. Oh, okay, open that. Didn't want that one. Let me drag that into there. Yes, it did. Okay, so I'm just going to copy and paste some code in there. I've pasted that in quickly so we can see we import this AWS IoT Greengrass core IPC component first of all, or module. We need to make sure that's installed on the device, but we'll handle that part in the recipe. So what we do here is we are just subscribing to a topic in the IPC. So the topic that we're going to define up here is this mypi/button. And when that happens, we are going to run this blink red LED function, which is just going to toggle the LED on and off so that we know that this has run. So it's very basic, and I'll include all the code on a GitHub repository so you can just copy and paste that as well. So we'll save that one, and then we'll go and do the next one. So let's open the recipe file for lighty that we've got here and see the changes that we've made. So we can see it's a bit of a step up from the last recipe file that we had. So first of all, we have a install lifecycle event. So we are running this script to install the AWS IoT SDK, which is required to communicate with Greengrass core. So with the Greengrass nucleus and the IPC that we need. Secondly, as before, we've put in that we require the privileges to talk to the GPIO. And then next we're running that artifact, which is the lighty.py file that we had. You'll also see that up at the top within the access control, we've added that part to the recipe. And what the access control does is allows the component to communicate, to publish or subscribe, as we've defined in here. So we're saying that we allow this to subscribe to mypi/button. So you can see here the Greengrass, aws.greengrass, subscribe to topic, mypi/button. So the IPC is only internal from component to component within the Greengrass application. In the next video, we'll move on. Instead of using the IPC, we'll use the MQTT broker to publish and subscribe back to IoT Core. But really what we're trying to demonstrate here is how your components can talk to each other when running on the Greengrass device. So I'll just save that. We can deploy Lighty straight away, but it won't work because we haven't done anything to actually publish on that. So let's go back and add in the code for buttony. Okay, I'll just copy and paste that. Here we are also importing the AWS IoT Greengrass core IPC, setting up the GPIOs for the push button that we have, and then the topic that we are going to publish on is the one that Lighty is going to be listening to, which is mypi/button. And we're going to just attach or put a message in there, but it doesn't really matter for now because we don't have multiple components all talking to each other. We only have this single component or 3 components that we'll finally have. So what we're doing here is as soon as the button is pressed, it's going to run this callback and then publish the message to the IPC within this. So, and then we have this sleep timer to keep the thread alive. So with all of these components, if you don't put that in there, it's just going to run and then stop. So we add this in. It's not really the best practice to do it in the way that we've done it in these examples, but we can go into that later on as we start to build these components. Really, it's about getting this up and running as fast as possible as our first challenge, and then we can expand from there. So let's save this file first of all, and let's copy across the recipe file. This recipe is very similar to the last recipe, except instead of subscribing, we're publishing. So we can see here that we allow within the access control, we're allowing IPC pubsub. Pubsub 1, which this is the policy name, which has to be globally unique on that device. So in this case, we are following the naming convention of the component itself, but you need to make sure that when you're merging these policies that you don't overlap or you don't lose track. And I'll show you a bit later another way to track how you can see that and visualize what's actually happening on the device. Similar to what we had, a bit belt and braces here as well, that we're going to install the AWS IoT SDK. And again, we will look at a better way of improving this. So having a separate component just to manage the installation of these packages is a better practice than having each component install that package or try to install that package every time it runs. And then the same again with the run command. We're just going to run the artifact that we have, which is this Python script. So I'll save that one as well. Then that's it. Close back to there. Now we'll open a terminal window and deploy these 2 components to the device. And the command is as we used before. So we have the deployment create, the recipe directory, the artifact directory, and what the component we wish to merge in. So let's do buttony first. Okay, it says it's been successful, but let's check to see that that's running. we'll use the component list command to check. And hopefully we should see buttony is running. In there, yep. Okay, great. That's in there. So we've got Blinky and buttony running. So let's add lighty. I can just change this one. Give that a few seconds to install. Great, and let's check that is installed and in the running state as well. Right, we've got lighty, buttony and blinky all running. So let's have a look on the device and see if it works. So we should see the green LED is still flashing. There you go, that's great. And what happens when I push the button? Yep, buttony makes lighty go on. So push it again. So that's all that's happening. So we know that the one component is talking to the other component via the IPC. There is a better way to visualize these components that are running on the device. So if we switch back to the AWS console, we just want to check that you have this component installed. So go to your core devices, and then my one in this example is MyPy. And we should be able to see which components we have installed. So I have installed the nucleus, the local debug console, and the CLI, which should be the same for all of you. If not, you can revise that deployment. What you will see is that there are none of the local components are showing here yet, because we've only deployed those locally on the device. The next stage is to push those back up to the cloud so that we can then deploy those back out to other devices as part of the rollout of this setup to all of the devices. So as long as we have the local debug console installed on the device, we should be able to use it. Let's switch back to the device. And here, you will see that the local debug console is running on the local host under the ports 1441 and 1442. So initially, if we try to log on to localhost 1441, we should see that. You might see a warning the first time you do this that shows you that this site is unsecure because there's no certificate attached to that. I'm not sure I can replicate that now that I've clicked the button to say to go ahead. But in order to log into the debug console, we need a username, a password. So if we put in debug, we still need to generate the password. And the way we get the password is by running this command, get debug password. So using the Greengrass CLI, we run the get debug password, and this should respond with the password that we need to log on. And there it is in that message. So if I just copy that and then paste to the other window, we can see all of the components that are running in a much nicer visual representation. So we can see also in here the dependencies. So as I mentioned earlier, we may want to move some of those installation scripts or installation components or packages that we need to their own component, and then have these components reference those components or have those as dependencies within their recipes. So if we go into any one of these components that we already have, so let's take for example Blinky, first one that we did, we can see the configuration file that's running within that device. So here we had the sleep time as a value at the top in order to flash the LED. We can actually see that in the lifecycle script it has changed that and pulled that value in. So what we can do here is I can change this down to say 1 second and then save that and stop and start that component again. We should see that the LED is now blinking faster. So here we can change the actual recipe at runtime or help you debug what's going on with your components. And it's a very useful tool to be able to visualize those components. So let's have a look at a few of the others. So we should be able to see within the nucleus and in the nucleus recipe everything else that we've got running on that account. So we can see our credential endpoint, the region that we're connecting to, and some of the other values that we can stipulate in there around the nucleus configuration. So setting up the spooler or various other JVM options that are in there. So have a play with the local debug console. Again, this is an open source component, so you can contribute to that component as well if you want to make feature requests or anything else that's available online to do that. And that's enough for this video. In the next video, we'll go into better ways of developing and better ways of deploying these components to the device. So I like to use Visual Studio Code, and that has the advantage that we can connect to the device remotely and also do port forwarding for things like the local debug console and visualize those on the local machine. It's also a nicer IDE for doing some of these Python scripts and everything else that we need to do on the device. So in the next video we'll run into that, as well as upgrading these components to actually talk over the MQTT broker so that we can see the messages coming back in on IoT Core, and then we'll actually make it so we can mimic the push button command remotely and watch the lighty LED flash every time that's done.